Not dark yet this time. It's that time of year when it gets dark later and later every day. So definitely brightest that direction. Swing round here, it's darkest the opposite way. And that direction is well, that's which way the light side of the moon is facing. Is anyone at all surprised by that? I thought maybe coming out while the sky is still blue rather than black, change the amount of contrast you get, make the dark side more visible, and I think I've succeeded in that. I think it's worked. I was going to come out last night, but it was cloudy. It's annoying because last night would have been interesting for one reason, having to do with me needing fine adjuster screws on this tripod. Well, you get a telescope, you get screws you can turn to just very slowly adjust it. All I've got here is tighten and loosen. I thought might have been interesting last night was right at the bottom. The video I got the night before last, a little tiny piece of the lit side visible, but broken off at the bottom, hidden behind something high enough and just on the dark side of the terminator to cut it off from the rest. Which may be visible at the bottom end of the terminator now. Maybe. Somewhere up there, according to something I just saw on the internet, on the far side of that rock, is what's left of Israel's attempt to land on it. Apparently it went wrong. Came down upside down or something like that. Which is unfortunate. The other thing to compare here to the previous video is of course the position of that terminator line. It's almost 48 hours later. Not exactly, I should note the creation times of the files and put that in the description for this one. It's almost 48 hours later and that terminator line is further round. And on both you should almost be able to see the ends of it, and you can see enough of the outline to figure out where the rest of the circle is. Just pick any 3 points along the visible outline and plot the circumcircle of those three, the triangle which has those 3 points. See, GCSE maths, useful after all. As if it ever wasn't. And from that, having the circle, you can draw a diameter across it perpendicular to the middle of the terminator line, And then with the aid of your sine tables, you can mark out angles along that diameter for how many degrees away from perpendicular the angle subtended at the moon by the Earth and the Sun is. And if you make them as multiples of 360 divided by 27.3 degrees, you should get days, and this should have moved 2 marks since this time day before yesterday. If you want to get really fancy about it, you have to take into account the fact that we are only somewhere between 363,300 and 405,500 kilometres away from that, minus the radius of the Earth at this latitude and the radius of the Moon. We'll come up. So that what you're seeing isn't 108 degrees of the Moon's surface. It might be 179 or 178 or something, but it's not a full 180. Which means your marks along that diameter wouldn't be exact. And the calculations of where to put accurate marks would get a lot uglier than just sine. Yeah, I think you'd have to plot the sine of each day, or every 12 hours or whatever. In this case, before half moon. Calculate its actual position on the moon's surface, and then calculate the angle from an observer on the Earth's surface to that position on the moon's surface, all the way out and around to out of sight at new moon. And then convert those angles into fractions, and then use them to put marks on your diameter line. That's a whole lot of calculating compared to just sine of the angle times half that diameter.